Picture a star. Not just any star, but a colossal beacon in space, hundreds of thousands of times brighter than our sun. A giant so massive it warps the fabric of its own galaxy. For years, astronomers watched this behemoth, cataloging its every flicker, anticipating the grand, explosive finale all such titans must eventually face: a supernova, the most spectacular firework in the entire universe. Now, imagine they aimed their most powerful telescopes back at that same spot, and it's just empty. No bang, no fading glow, no cosmic farewell, just a silent void where a star used to be. And no, this isn't the opening scene of a sci-fi movie. This is a real cosmic mystery that's forcing us to rethink everything we thought we knew about how stars can die. What in the universe does it mean when a star can simply be erased? To truly grasp how bizarre this disappearance is, you first have to appreciate how stars are supposed to die. For the universe's most massive stars, their death is the single most violent event possible. It's called a core collapse supernova. After millions of years of turning lighter elements into heavier ones, the star's core basically runs out of gas. The cosmic balancing act between gravity crushing inwards and nuclear fusion pushing outwards is shattered. Gravity wins. In less than a second, the core implodes into an object of unimaginable density, either a neutron star or a black hole. This collapse unleashes a shockwave of pure power that rips through the star's outer layers, blasting them into space in a cataclysmic explosion. A single supernova can outshine an entire galaxy of billions of stars. It's a death that screams its presence across the cosmos. But something very different happened in a galaxy called NGC 6946. Because it's packed with supernovae, astronomers have affectionately nicknamed it the Fireworks Galaxy. For years, they used the Hubble and Large Binocular Telescopes to monitor one of its giants, a star known as N6946BH1. This was a true heavyweight, a red supergiant estimated to be 25 times more massive than our sun. It was a prime candidate to go supernova. And then it did something weird. Around 2009, the star suddenly flared up, shining about 1 billion times brighter than our sun. Astronomers got their popcorn ready, thinking this was the beginning of the end, but then it just fizzled out. They kept watching, and by 2015, it wasn't just dim, it was gone. The star that once blazed had completely vanished from sight in visible light. It was like a skyscraper disappearing from a city skyline overnight. They pointed Hubble at its last known address again and again. Nothing. It had ghosted the entire astronomical community, leaving behind a cosmic crime scene with no body, no weapon, and a universe of questions. It seemed the Fireworks Galaxy had a major quality control issue. Or maybe something far stranger was at play. Faced with this cosmic crime scene, the investigation had to begin somewhere. When a star 25 times the mass of the sun goes missing, your first instinct isn't to declare a new law of physics, it's to check if you plugged the telescope incorrectly. The immediate suspect is always error. Did the camera glitch? Is a sensor on the fritz? But one instrument after another confirmed the same baffling result. The star was not there. So the investigation deepened. What if the star wasn't gone, but just hiding? The universe is a dusty place. Maybe a thick cloud of cosmic dust just happened to drift in front of N6946BH1. It's a plausible alibi, and one astronomers had to eliminate. To do that, they switched from visible light to infrared. Infrared light can cut through dust like X-rays through a suitcase. They pointed the Spitzer Space Telescope, which sees the universe in infrared, to the star's last known location. If it was just hiding behind a dust cloud, Spitzer should have seen it plain as day. But it didn't. They found nothing but a faint, fading heat of whisper. So the dust cloud theory was officially busted. The star wasn't hiding, it had fundamentally changed. What else could it be? Maybe some bizarre, moody variable star that has extreme swings in brightness. Some stars, called luminous blue variables, are known to have massive outbursts and then calm down. Another vanishing star candidate, this one 75 million light-years away in the Kinman Dwarf Galaxy, was thought to be one of these. It too disappeared around 2011. But for a star this massive to just go dark? That would be totally unprecedented. Every normal explanation was hitting a wall. The evidence was piling up, all pointing toward a single unnerving conclusion. The star wasn't hiding, and it hadn't just moved, it had been wiped from its place in the cosmos. So where could a star that big possibly go? With all mundane explanations exhausted, astronomers were left with an answer that is both terrifyingly simple and impossibly powerful.
The name is both perfectly descriptive and deeply unsettling. It means that the most powerful explosions in the universe can just fail. Let's go back to that dying star. In a normal supernova, the core collapses and the shockwave is strong enough to blow the star to pieces. But what if the star is too massive? What if the gravity of its collapsing core is so ridiculously powerful that nothing, not even the force of a supernova, can escape? In this scenario, the core still collapses under its own weight, forming a black hole. A shockwave still tries to blast its way out, but it never makes it. The gravity of the brand new black hole is just too strong. The shockwave stalls, falters, and gets swallowed. The star's outer layers, instead of being blasted across the galaxy, get a final silent order: fall. And so the star just eats itself. All of it. The whole colossal body just falls inward, straight into the black hole it created. From our point of view, there's no grand explosion, no flash of light. In a matter of hours, the star simply winks out of existence. It's the quietest, most anticlimactic death imaginable for one of the universe's true giants. A silent implosion, leaving nothing behind. This is what astronomers think happened to N6946 BH1. The brief flare-up in 2009 was likely the star's final gasp as the core collapse began. And that faint infrared glow Spitzer saw later? That's probably the afterglow of the last bits of matter swirling down the drain into the new black hole like water circling a plug hole. If this is bending idea that a star can die not with a bang, but with a silent, all-consuming collapse. It changes our entire picture of how the universe works. If you're fascinated by these cosmic mysteries, make sure you subscribe and ring that notification bell so you never miss another journey into the unknown. This concept of a failed supernova isn't just a weird one-off. In fact, it has huge implications. For decades, we thought stellar mass black holes were born almost exclusively from brilliant, violent supernovae. Now we have evidence of a second, secret path, a stealth mode for making black holes. This helps solve a huge cosmic puzzle, the missing massive star problem. Based on how stars form, we expect to see the really big ones, 20 or 25 times the mass of the sun, exploding all the time, but we just don't. We see far fewer of these heavyweight supernovae than our theories predict. We've been taking a census of the cosmos, but we've only been counting the loud deaths. How many have slipped past us unnoticed? A hidden population of cosmic ghosts drifting through the galaxy, their existence only given away by the star that isn't there anymore. And yet, while the failed supernova theory solves one major puzzle, it might not be the only explanation for a vanishing star. Another even more ambitious search has shown that the problem of disappearing stars is much, much bigger. Enter the VASCO project, which stands for Vanishing and Appearing Sources During a Century of Observations. Its goal is breathtaking. Compare the sky as it looked 70 years ago to the sky today and find anything that's changed.
Researchers digitized old photographic plates from the 1949 Palomar Observatory Sky Survey and compared them to modern surveys. They started with 600 million light sources. After years of painstaking work, they've identified around 100 unexplained transients, points of light that appeared on old plates but are nowhere to be found today. And here's the kicker: that number is way higher than failed supernovae alone can explain. The Vasco results suggest something else is going on. The project has unearthed historical cases that are still complete mysteries. In one jaw-dropping instance from 1950, a photographic plate caught 9 star-like objects in a tiny patch of sky that appeared and then vanished within half an hour. No known astrophysical event can explain that. These aren't just glitches, they are records of celestial events that defy our understanding, hinting that the silent collapse of a star might be just one chapter in a much larger, weirder book of cosmic disappearances.
This revelation naturally leads to the next question. If they're not all failed supernovae, what are they? This is where we get to the very edge of our knowledge, where science meets unsettling speculation. Could we be seeing totally new types of cosmic events we haven't even theorized about yet? Some have suggested extreme dimming events, or maybe brief flares from otherwise invisible objects that we got lucky enough to capture on a single photoplate. But these explanations don't quite fit most of the cases. The researchers behind Vasco even cautiously acknowledge that their search is relevant to SETI, the search for extraterrestrial intelligence. Could a civilization advanced enough to harness the entire energy of its star make it appear to vanish? It's a wild, speculative leap, but for a handful of these cases, it hasn't been ruled out. What we're left with is a profound sense of mystery. We have a solid theory for some vanishing stars, the failed supernova, but we also have a growing list of cosmic ghosts that don't fit that profile. What power could erase a star from the sky? Are we witnessing the birth of new cosmic objects? Or are we just seeing the limits of our own understanding, a sign that the universe is far stranger than we ever dared to imagine? Ultimately, all these unsettling possibilities bring us back to one central point. The story of the vanishing star is a chilling reminder that the universe is not a static, unchanging stage. It's a dynamic, violent, and deeply mysterious place. We've learned that a star can die not in a blaze of glory, but in a silent, suffocating collapse, winking out of existence to leave a black hole in its wake. We've actually watched it happen. This discovery solved one mystery, the case of the missing massive stars, only to reveal an even bigger one. Projects like Vasco have shown us that the cosmos is littered with these disappearances, more than our theories can currently handle. Each one is a puzzle, a ghost in the cosmic machine. Astronomers are continuing the hunt, using the incredible power of new instruments like the James Webb Space Telescope to peer into the last known locations of these vanished stars, listening for the faintest whispers that might tell us where they went. So the next time you look up at the familiar, seemingly eternal stars, remember N6946BH1. Remember that the stars are not forever, and some, it seems, don't even bother to say goodbye. What do you think is causing these stars to disappear? Are they all just failed supernovae, or is there a more exotic explanation lurking in the darkness? Let us know your theories in the comments. For more deep dives into the universe's biggest mysteries, make sure to like this video and check out our playlist on the unexplained phenomena of the cosmos. Thanks for watching.